Good evening, everybody. Delighted to have such a fantastic audience with us this evening, and also delighted to welcome our speaker for the evening, Dr. Theodosis Mourouzis, who is actually our expert in residence on blockchain at London Business School, and certainly knows a thing or two about the subject, as well as artificial intelligence as well, which I've just been chatting to him about, actually, to try and get a little bit of a heads up in terms of really the distinction and differentiation between the two areas. So when we put this event together, we thought it would be an ideal part of the entrepreneur's journey for aspiring entrepreneurs looking to upskill, and not necessarily those who are coders, but actually those who, especially coming from London Business School, are more proficient in terms of the commercial acumen of running a business. But that said, it's always great to be able to understand, of course, the various components, and especially the technology which enables commercialization to happen and to drive the business forward, and hence the need to understand and put in perspective the importance of blockchain in today's modern day businesses. So, as I say, delighted to be able to welcome Theodosis here with us this evening, Theo, as he otherwise likes to be known, and he'll be taking questions throughout the session. So, before we hand over, just also to make it apparent that those of you who wish to get involved in blockchain, distinct from actually understanding it from the perspective of how it would impact on your business, or whether you're in a startup or starting up on your own, then you can actually get involved with the school's blockchain club, and I'll put some credentials here on the screen for you. So welcome you to reach out to one of our MIMs who's leading that, and his details are on the screen as well. So please do join in with the initiatives that they're running specifically on blockchain. Finally, just to understand, to help you keep in the loop of everything that's going on at London Business School with regard to entrepreneurship. I work within the Institute of Entrepreneurship and Private Capital at the school. We embrace not only entrepreneurship, but also private capital, as the name would suggest, in terms of working with VCs, PE firms, and obviously all aspects of the entrepreneurship ecosystem. So do reach out to us if you feel that there's anything you would like to be able to get involved with if you're not already at the school. Do follow us on Twitter and our Start Hub blog as well. You're welcome to sign up there. Details of various initiatives which are running throughout the year, as well as this ongoing series of the Entrepreneur's Journey program, with our next event, in fact, being next week, specifically for those at London Business School who are able to come and meet the businesses in our incubator program. That's November the 10th. So do sign up for that if you are at the school. Other than that, feel free to reach out to us. As I say, our contact details are on the screen, and we look forward to chatting to each of you, to be able to get to know you better. So handing over now to Theo.
Okay, thanks, Jane, for inviting me today on this webinar. Thanks all of you who attend the webinar today. It's my pleasure being with you today, and honored to be invited by Jane and the Institute of Entrepreneurship Private Capital at London Business School to discuss about the new technology of blockchain technology and how this can be applied to pretty much any sector, and in particular into the financial services. So as Jane has already mentioned, as I present, I will accept questions. So just like interrupt me, ask the question, because the time is limited. And also I'll provide my email at the end of the session, so that if you have some further questions, we can take them offline in case there is no time. Okay, so let me try to share my screen now. Okay, so tonight, what we're going to try to do, we're going to make a fair introduction into the world of the blockchain, and I promise I'll try to skip most of the technical stuff, but because blockchain is a very complicated technology that is like the celebration, especially of cryptography and many other mathematical sciences, we will just refer to the technical stuff whenever it's needed in order to understand what is the main reasoning behind this technology. So my name is Theo. Theo Mourouzis. You can just call me Theo. My interest is in cryptography and blockchain in particular. I have a PhD in cryptography from UCL, and I was a mathematics graduate at University of Cambridge, and also now I'm blockchain mentor to London Business School, and in particular to the Institute of Entrepreneurship and Private Capital. I have a lot of experience working with blockchain technology, not just from the advising level or consulting level, but building real products. And I have worked with many big organizations and companies, which some of them I list here. And I have worked also with governments in order to help them devise their blockchain strategy and best practices in regards to application of blockchain across several sectors. I'm the managing director of Electric Consulting, a small boutique consulting firm specializing on emerging technologies, and in particular blockchain, distributed ledger technologies, as well as artificial intelligence, data science. And we have a lot of experience end-to-end in the blockchain space through different application of blockchain technology, like decentralized finance, tokenization, smart contracts development, audit, crypto exchange setup, and cryptography research and development in general that are being used in the blockchain environment. So what I will try to do in the next 40 minutes, I will try to take you through a journey from the birth of blockchain technology, how this appeared, and actually what is the state of the art nowadays in regards to application of blockchain, as well as challenges and limitation. So blockchain, as you see in the diagram here, it's like the evolution of money. As we all know, money, it's a very complex notion. Initially, when people realized that they would like to start doing some sort of trading, they came up with ideas of bartering. This type of bartering led to some standardization issues. It was very hard to pretty much understand what value is exchanged for what other value, so that people came across of different methods of standardizing the trades. And that's why we have the asset-backed currencies like gold being used initially, then metal coins, then paper coins. Then with the birth of the internet, we have plastic cards and electronic money. And we have finally cryptocurrencies or blockchain-based currencies that seem to be the future for governments to build their own digital currencies to be used for eliminating the paper-based payment methods. As I've already said, we started for bartering, then there was a need for standardization, which led into the development of payment systems. And today, 2020, we are very close in having something called the Internet of Value, which will be a layer on top of the internet that will allow users not just to exchange information freely through the network, but also be in position to transact in a completely paperless and digital way. JP Morgan says that blockchain is laying the foundation of digital money, and it's pretty much accepted that blockchain is the technology that is going to be used in order to pretty much disrupt the whole financial services sector, but also will be the technology on which the new monetary systems will be based on. We know that certain countries already started studying how to devise their own central bank digital currencies. We have the example of China, UK also, they started experimenting with their own digital currency based on RS coin research. And in general, it's a matter of time when all the countries will have fully digital currencies based on the blockchain technology being used as the accounting ledger behind it. According to the same article, 2019 will be remembered for the rise of digital money, which happened. And the bank also said in the report that the groundwork is now in place for more mainstream adoption of blockchain technology at the same time that the foundation is being established for the development of digital currency and fast payments, especially cross-border payments. And we have this new evolution of private money that is very popular nowadays. And we have cryptocurrencies, as they call, or digital assets, becoming mainstream and pretty much used across different sectors for solving different issues. However, as you might already know, this comes with many challenges. For example, auditability, anonymity, KYC procedures that they have to be applied, also volatility, which all these things will somehow be controlled at some point when the governments come up with like a proper regulation in order to regulate, but do not kill the technology at the same time. So at the moment we are before the era of this like technology going full mainstream, and the government start hopefully realizing how to regulate and make sure that this technology can be used and be secure for the investors. The adoption on the other side grows exponentially. According to several sources that you can go and check out there, it seems that more and more people are using digital currencies. For example, 21% of Americans are already familiar with this new technology. You already know the El Salvador case, where they just made the Bitcoin as a legal tender, and more countries will follow. I'm not saying Bitcoin is the way to go, definitely might not be the way to go, but blockchain-based digital currency is the way to go for the future for completely digital payment systems. This example shows here how the Bitcoin network increased, and we experience here something called the exponential growth. So what we experienced with other technologies in the past, like smartphones, internet, and whatever other technologies that disrupted our society, is that in all cases, we have pretty much observed this exponential phase of adoption. The same applies with blockchain, and it seems that it's very likely that this technology is going to become very, very mainstream at the end and being adopted in many applications in different sectors. So let's try first to see how this technology appeared. Blockchain technology appeared when a bunch of anarcho-capitalists embraced the idea to have a currency not issued by state that could be exchanged freely without the need of any financial institution. So this was the manifesto, the crypto-anarchist manifesto, as you see here, by Timothy May around 88. And the whole idea was to be in position to design a system that is controlled by its peers without having a central authority being responsible to oversee the transactions, and at the same time, everything happens in a very transparent way. And it seems that Bitcoin, that firstly appeared in 2008 by anonymous person or group of person under the name Satoshi Nakamoto, solved this issue of decentralized and fair governance of a monetary value in a very fair way. And this actually did not happen by miracle. It was actually the long-term research of more than 40 years of cryptography and engineering work that they were trying to solve such a problem. The problem was to devise the first complete peer-to-peer e-cash system. And after 40 years of research, Bitcoin protocol pretty much combined all these very nice technologies together. As you see here, I'm not gonna go into these technologies separately because they are very, very advanced. But what you need to understand is in this Bitcoin protocol that gave us the blockchain idea, it was a very nice, elegant combination of several other pre-existing technologies. There was actually no new technology, but just a very elegant combination of already existing technologies. Three persons played fundamental role in the inception of blockchain and the potential for digital payments. I just list these persons here in case that you would like to emphasize more and understand more about this historical evolution of cryptographic research that led to the birth of the blockchain technology. David Chaum was actually the first cryptographer who tried to build the first digital currency system. Then Adam Back, who designed the proof of work consensus algorithm being used in the Bitcoin protocol, which is a set of algorithms and rules that need to be obeyed for the transactions to be valid, as we're going to see. And Scott Stornetta, who devised the idea of the blockchain, which is the accounting ledger behind this decentralized ecosystem of transacting nodes, of transacting peers. Okay, these three are the main technologies that actually have been combined elegantly, and they gave us Bitcoin, which was the first peer-to-peer e-cash system. And the whole idea with the blockchain is that we have a ledger, we have like a database that is distributed, which means that it's not in one place and you can attack it. It's pretty much everywhere. Every participant into the network has this ledger, which is called the blockchain. And whenever we write on this blockchain, it needs to be approved by the whole system in a very democratic control or consensus algorithm as called formally. And this democratic control or consensus algorithm is something that it is written into the programming language, into the software, and it's open source, so we know exactly what procedures have been followed for ensuring that the transactions are okay. So in a nutshell, everything is transparent regarding transactions on the ledger. Okay. And when Bitcoin appears, it was pretty much against the banks initially. That's why the first message that they have written on the first block of transaction was this one that you see here, which was about against the existing financial sectors. But what I want you to keep from the Bitcoin protocol is not the Bitcoin, but the blockchain behind this Bitcoin protocol, which is like its accounting ledger. Okay, if you are interested to learn more about how this blockchain system has been used firstly as a accounting ledger behind a completely peer-to-peer electronic system, this is the paper to go and have a look at it, definitely. Maybe after the webinar or when you have free time, which is called Bitcoin, a peer-to-peer electronic cash system, which pretty much describes how this blockchain works. And the whole idea is that everyone can be of this ecosystem, which means that everyone can download the software and can be nodes of this network. What does this mean? It means that whenever you are going to do a transaction, you are going to transmit through the software this transaction to the whole network. Everything is going to be transparent because every transaction that happens among the peers of this network is being validated in a secure and in a very transparent way. And as soon as the history of the transaction is there, nobody can dispute it. That's it. It happened, which means that there is no place for forgeries. There is no place for disputes or whatever. Whatever the system says, this is the real case because everything is encoded and dictated by the algorithms that are programmed into the system. Okay. And all these nice properties that blockchain has are pretty much guaranteed through advanced cryptography. I'm not going to go into details because of limited time, but what I want you to understand is that blockchain is like a distributed database. It's a ledger which is maintained by a full group of nodes, by a set of peers, and the rules into this ecosystem consisting of this set of peers is written into the software, which is open source, and you can see. Okay, so this is pretty much how a blockchain works. So how a blockchain works: someone requests transactions which say, "Hi, it's Theo. I would like to send to Jane this amount of, let's say, Ethereum or whatever." Okay, then I put as inputs into my software the address of Jane, the amount I would like to send, and then I transmit this through the network. Then the network validates that I have enough balance, I have not spent this money before, I can make a transaction, and I really have the authority through something called the secret key to sign a transaction. And then this transaction is populated under a set of other transactions. And then the whole system together, as you see here, this red cube, start working together in order to validate the transactions, say all these transactions are okay, and they apply secure cryptographic protocols in order to approve the block of transactions and append this block of transactions to the previous historic data. And I'm not going to go into this detail, but the magic that happens here is when you glue this red cube with the previous gray cubes using advanced cryptography. And this gluing is happening in a way such that nobody can go and change data at any time of history, because everything is glued together very, very securely, which means that if someone is going to change the history of the transactions at any point of time, they have to go and change all the data before this. And it turns out, because of the algorithms that are being used, this turns to be impossible to happen. I know this might be a bit technical, but this is like the backbone behind this technology. The idea is that you can only do something into this ecosystem if you are authorized to do, and whatever you do, transacting or any other type of application, everything is recorded in something called the blockchain, which is the ledger, and this cannot be disputed, which means that there is like a full transparency into the ecosystem. What are the properties of this whole system, of this blockchain? Decentralization. We've said so far that there is no single party or the central authority overseeing the transaction. Everything is encoded into the system, and all of them collectively need to approve the transactions and give the final approval for these transactions to be executed. Auditability. As we've said before, every person can join the system and can keep a record of this ledger, which has all the transactions. Participants of the network can verify the veracity of the records directly. So in terms of auditability, it has very nice properties. Accountability. As soon as something has been recorded, if the transaction which says Theo sent 1 token to Jane is approved, then I cannot later deny that I did this. Neither Jane can deny that she has not received this amount. As soon as something is recorded and validated, then it cannot be changed. Construction of direct trust is another property of blockchain. Unknown and untrusted parties can operate without the need of third-party intermediation. All this very nice orchestration of transaction happens without me knowing anyone in the ecosystem. Everything is in the code there, and we trust the code that runs the system because it's open source, and there is a critical mass that actually makes sure that this set of rules is being followed as expected. Elimination of single point of failure, because there is no central authority. So everything is agreed in a collaborative and distributed way. Extra security, because of the distributed nature of the transactional database that we have, and also because of state-of-the-art cryptographic techniques being used in order to secure the network, and especially the blockchain, which is the ledger, the recording database ledger behind the network. Reliability, resistance to outages and manipulation, because it's like a big system of people interacting. Finality, all members of the network know which the true state is. And how is this? Everybody has access to this set of cubes, as you see here, the gray and the blue ones. This is the truth. These are the transactions that happen, and these are the transactions that are happening now. So we have a truth state that is known by anyone, and this truth state is encoded into the blockchain, into the distributed database. And except of just having a blockchain, we can have additional feature called smart contracts. Ethereum was the first, actually, framework to introduce smart contracts into the blockchain environment. And smart contract might be a topic for another discussion, but what is a smart contract? Blockchain is this distributed database that records the transaction. Smart contracts can be scripts that can encode conditions among the peers of the system. For example, they say, if this and this happen, then this reward code to go to this address. So you can devise and do some like smart execution into the system if you want, through something called smart contracts. Other properties, transparency, because the ledger is public, you can go online and see and check that everything is fine. Immutability, as we've said before, we are using state-of-the-art cryptographic techniques so that nobody can dispute and nobody can alter the transactions. Ownership is linked via something called the private key or digital signature. So this very elegant cryptographic design called digital signature makes sure that when a transaction is conducted by you, it's unlikely that has been conducted by someone else, because you are supposed to protect something called the secret key. And this secret key is so secure that it's unlikely for someone else to predict it at random. Okay, which means that ownership is fully guaranteed as soon as you apply some very simple security best practices. And operations are streamlined and unnecessary middlemen being removed, which is what we call computational logic. Imagine the example of supply chain. Something is being posted, let's say, from China to UK, and it goes from like several countries in the middle, or any other example. There are many cases where things are being lost because of the complex supply chains. And why this happened? Because each, let's say, person, participant, entity being involved in this supply chain, they might be using their own centralized database. If you onboard all these entities into a blockchain-based system, which means that all of them know what is actually happening now, you can orchestrate and streamline all the operation, which means that blockchain can be used in order to linearize the complexity of communication, because all of them will be onboarded on the same software, and all the rules will be there, and know how, when these rules have been triggered, and what is the action and actions taking place in this ecosystem, against the scenario of having each entity having their own legacy systems or centralized databases, where confusion is something that it's inevitable at the end when there are many communications. So the whole idea with the blockchain is that you have a ledger that records everything. Everything is being appended when like the full set of nodes agree that all are okay, and everything can be nicely queried. The problems that have been solved, and Bitcoin was the first actually to initiate such a revolution in the financial sector, it's these three problems here: no counterfeiting, no double spending, and transaction irreversibility or immutability. I'm not going to go into more details on this, but the technologies that allowed us to make sure that this is not issue anymore in case of digital currency, we are firstly introduced in the Bitcoin protocol. And especially the double spending was a very, very important problem to be solved, and very challenging one. Okay, so 2008, we had the Bitcoin proposing blockchain as an accounting ledger in the monetary system being introduced. And 1 year later, 2009, we have Bitcoin becoming open source. And still there is lots of controversy around Bitcoin. Definitely nobody knows, maybe it's international currency, bubble, or store of value. Here you see how the volatility of prices, I mean, it's a very volatile asset if it's considered or an asset, but Bitcoin is the like the reason behind this evolution of private money. I don't know if you know this webpage, coinmarketcap.com. If you go on coinmarketcap.com, you will see many, many different projects being represented by their own token and having their own blockchain recording the transactions that happen with this ecosystem. Okay, you can have as many as you want. Not all of them will survive pretty much, but the revolution of private money, the revolution of blockchain-based monetary systems has already initiated. And what we will observe, actually, it's what we see in this curve here that happens with all the nascent technologies. The whole idea is that when a new technology appears, you have the stealth phase where some people believe first and they make some smart money. Then we have institutional investors realizing that this is like a true technology. This is where we are with blockchain now. Lots of institutions, big banks got interested in the blockchain technology. Then you will have the mania phase, and then the blow up phase, and then something called regression to the mean. At the moment, in the blockchain space, even if it's like 11 years old technology, we are still in the institutional investors level. And we started understanding what are the real application of this technology, and started moving closer to the mean case where we expect the hype to go down and more real and pragmatic situations, use cases surviving, as we are going to see. Okay, so if you would like to experiment with blockchain, there is still a lot of opportunity out there. There are a lot of like VC funds, there are a lot of like hedge funds interested in this quite new technology. Even if it's like 11 years old, it's still very complicated to consider as mature one. The economists characterized blockchain as the trust machine for the obvious reasons that we've discussed before. And it is claimed that the internet allows for free flow of information, but blockchain allows for money and trust to be exchanged on top of the internet layer. Okay, some very interesting statistics. Deloitte predicted that 10% of global GDP will be built on top of the blockchain by 2025, approximately $12 trillion. Now we have like almost $2 trillion asset class valuation. Morgan Stanley suggests that blockchain in transportation is a $500 million opportunity in the US alone, because blockchain has the potential to bring stakeholders into the same like environment, so that transportation and supply chain are very, very good candidates for applying such technology, because we have multiple parties involved in complex like operations. This is a very, very interesting diagram here. Do you really need blockchain? As we've said, blockchain is a distributed database which is used to record transactions among a network of peers. It turns out that in most cases, you don't really need blockchain. Okay, so in case that you have a use case that you would like to study, you can go through this flow chart here. We will share the slides with you and understand if this is something that blockchain will add value on it. Okay, and there are different types of blockchain. There is a public blockchain like Bitcoin, Ethereum. There is a private blockchain, which is a blockchain where the nodes, the peers of the network are approved entities. For example, in the supply chain, I'm not going to allow anyone to enter the supply chain blockchain. I know which parties are involved. So I will create a blockchain that I will just onboard on this blockchain only the involved parties. We are talking about a private blockchain now, okay, or a combination. Really depends on the situation. As a rule of thumb, if you would like to apply blockchain, it means that you have either a trusted nodes that you need to bring into the same ecosystem and let the software dictate how the state of the system will be, or you have complex relations among multiple parties using their own centralized databases, and you would like to build, let's say, private or a hybrid blockchain in order to streamline the operations and linearize the complexity of communication among these peers. We said before that everything is transparent and everything is auditable. Practically, let's get the example of Bitcoin. If you go to this website, blockexplorer.com, what we've said before about transactions, everything is online. You can go and see what are the transactions now, what were the transactions before 5 minutes, how much Bitcoin have been transferred from one address to another address. As you see here, everything is pretty much obfuscated. It's like you have random looking strings transacting among them. These are encodings of the users of the system because the system is a pseudo-anonymous. But this like webpage, blockexplorer.com, it's a visualization of the blockchain. Each token that we've seen before, or if you are gonna deploy a blockchain as here, then you need to have an explorer that will allow you to pretty much trace all the transactions. And you see, you can create some graphs, for example, and you can trace the funds. So this is a very nice property, auditability. It will be a very nice tool for governments to have blockchain-based monetary system because everything is transparent. As soon as you enforce it in the right way, then it's a very good tool. And you can do forensics, you can understand what might go wrong. If you have further intelligence with your blockchain-based ecosystem, you can pretty much see an imminent fraud or a problem that might arise in the near future. Okay, however, there are cases that you can't do anything, and this is a problem for the regulators, where you have the so-called privacy-preserving technologies being used, like, I don't know, there are tokens like Monero, Dash, or whatever, that you cannot really trace and do these nice graphs to avoid money laundering, fraud, etc. Okay, but each technology, it's usually of dual usage, right? It comes with good things, it comes also with bad things. So it's up to regulation to decide about what they can do with these privacy preserving tokens that provide full anonymization into the ecosystem of the blockchain. Okay, and examples of anonymization, you can have like privacy at origin level, sender levels, or transactional level. You can have like mixer technologies that are being used in order to hide the tracks of the transactions, several privacy preserving technologies. And if you are interested to understand more about the privacy preservation, you can go and check these tokens here that offer full anonymization. The reason I refer to these privacy preserving technologies is because in financial services and in securitization in general, there are big studies around that say how blockchain can be used in order to help the securitization sector by making some illiquid assets more liquid. For example, real estate. You can have fractional ownership. You can have a building, I don't know, in London and sell it across the world, and you can just split it in chunks and sell it to as many investors as you want. These privacy preserving technologies are good to be applied with blockchain in the securitization space because in securitization you need to have privacy. Okay, and this is guarantees via certain cryptographic primitives that it's out of the scope of today's like seminar. And there are examples in the sector, financial sector, like Polymath, that is a blockchain for launching securities. Let's say you have a project which the idea is to buy a hotel, create tokens that represent this hotel, and then sell these tokens to investors. Then you can use blockchain to do that, because blockchain will allow you to link the physical asset with the digital world and sell it by following certain procedures and certain regulatory requirements. Other applications that we observe, we are moving from Web 2.0 applications to Web 3.0 application. There is a very common like quote saying that the data is the oil of the 21st century. Okay, data is very, very important. You see all these big companies on the top row, Google, Facebook, Dropbox, Skype, they all make money out of data. There are multi-billion giants sitting on the leverage of data. Now, with Web 3.0 dApps, the whole idea is for this data and for these companies to be completely decentralized, which means that if there is a YouTube now, it's going to be a version of YouTube which is fully decentralized. And if you are creating very nice content, you will be rewarded more because you can sell your data. So blockchain will allow the data monetization of the personal data that you have. That's why you see this evolution now. We are moving from Web 2.0 to Web 3.0, where there is no ownership. There is just governance by some company, but everything is very transparent and recorded on the blockchain what is actually happening. Tokenization. I'm sure that you have heard of the word tokenization, a very nice application of blockchain, which you can use in order to tokenize fine arts, antiques, land, technology. I'm sure that you've heard about NFTs, artistic creations that you can use on and use blockchain in order to sell them online. And asset tokenization, it's a process that you can follow if you are interested in making a startup in asset tokenization. For example, startup for tokenizing, I don't know, real estate, paintings, or whatever you can think of that will add value. Okay, so if you plan to tokenize something, or if you plan to finance a new venture using blockchain technologies, you have to understand, first of all, what is your use case and what is the token that will be associated with this blockchain in case there is a token being involved. And we have in general 3+1 type of tokens. The first one is a payment token. If you are creating a blockchain ecosystem that can be used for payments. Utility token, if you are creating a blockchain ecosystem and the token is being used to unlock, let's say, some special features. Security tokens, if you are planning to go through securities, tokenize an asset, for example, and sell it to investors, or hybrid tokens that are like combination of these three different types of tokens. In the past, there were many crowdfunding campaigns based on blockchain that startups actually raise capital by first having the idea, then let's say in quotes, tokenizing the idea and carrying out something called initial coin offerings in the past, now which was like the reverse of the IPOs. Okay, and now we have the security token offerings. The whole idea is that you can go and try to get some retail funds by tokenizing your project. If you have a blockchain-based project, there is a token associated to it, then you can use this token to raise funds. So blockchain can be used also for financing new ventures. And there are also other applications of blockchain, for example, in the financial sectors. MasterCard released a blockchain-based API for sending money over the blockchain and also using the blockchain for the provenance of luxury goods. If you buy something for a high brand, from a high brand, then there is a special code that if it goes through MasterCard, you can trace this and make sure that this is authentic if you are going to buy a second hand or if you are going to sell it. And we have many other initiatives in the financial sector space. SWIFT is going to be replaced by other protocols. SWIFT is the main payment system used for transactions. JP Morgan is using their own blockchain for internal payments. And you know about Facebook, except of the metaverse that they announced like a few days ago, they will have their own blockchain-based currency, which can be used for paying through the messenger. Okay, and they are going to use blockchain for providing fast peer-to-peer transfer of money across the Facebook users. And many applications of blockchain in general. I'm not going to go through all of them. I will provide the slides. Internet of Things. Imagine a future, everything is interconnected. Then your fridge, for example, will be in position to alter some milk and pay automatically through digital currencies. This might look to be science fiction, but it's actually something that we are very close to it. Payments, very important. Intellectual property and copyright. Blockchain and strong cryptography behind the blockchain make sure that you can actually claim that you are the original author of let's say, creation of art. Nobody can dispute you unless you are the first to record this thing on the blockchain. Voting, taxation in general, finance is being pretty much redefined now. We have the term decentralized finance, where startups are trying to use blockchain in order to decentralize how finance world operates. You can have decentralized banks based on the blockchain, decentralized payment systems, decentralized hedge funds, lots of different applications that you can think of. NFTs, very, very popular nowadays, non-fungible tokens that are unique and non-interchangeable unit of data stored in digital ledger. If you go online check for OpenSea.org, you will see paintings there being sold for different tokens. Okay, these paintings are like creation of mind, creation of art. It's the first time in history that we have a technology that solves the so-called digital rights management issue. Before, it was very hard to make sure that the digital unit was not being copied or cloned. Now with blockchain, we have this ability to make sure that we secure who created what. Okay, NFTs looks something like this. Maybe you find some of them not worth their money. I'm not here to judge, but I'm here to say about the evolution of this technology that allows to pretty much register the IP of a creation of mine. Okay, so here you see some like expensive NFTs. The first one was sold for around like $70 million. And we have several examples here. Now, what I've said before about the blockchain, let's say that you have your startup, you need to understand what type of blockchain you are going to use. Are you going to use a public blockchain, which means anyone can be part of the ecosystem, or are you going to use a private one? Are you solving a particular problem for a particular industry where on the blockchain you need only particular peers entities to be onboarded? Based on this, you are going to decide if you are going to use a public, a federated, or a private blockchain ecosystem. Okay. Security, when you are going to design your blockchain system, it's the #1 priority. Blockchain has a lot of moving parts, and many moving parts means higher surfaces for the attackers, more complex interactions. Here you see examples of lots of millions of losses because of security vulnerabilities found either in software or in the algorithmic design or in the implementation or in any type of like a possibility that you can think of. And we have many cases of exchanges being hacked, of software being hacked, and many other like financial related products being hacked. The other thing that you need to take seriously into account when you design your blockchain system is where these private keys that are being used in order to claim tokens that they really belong to you or to unlock specific features into your blockchain ecosystem, you have to make sure you know how to protect them through proper secure wallet infrastructure, as it's been called. Okay, so the whole idea, as I've said before, is that whenever you interact into the blockchain system and make a transaction, you have a secret key. Secret key is something that you need to keep secret, and you keep it secret by keeping it safeguarded into something called wallet. Okay, and the best practice is to make sure that this secret key, which is like a piece of information, let's say 256 bits, you keep it away from the network. Okay, and this is called like a cold storage type of security wallets. And this is the best practice if you are planning to launch a token-based blockchain product in the future. Okay, here it's a guide about different type of wallets that you might have in order to protect your secret keys. You can encode even more advanced features into these wallets. For example, if you plan to build the new decentralized bank of the future and you have funds represented by digital units, then definitely you don't want to have all of them under your secret key. So you encode something called multi-signature, where you can bring more people in and encode proper security procedures and policies. For example, you need 5 out of 6 persons to unlock the funds, and so on. The space now is very mature, and you can pretty much apply relations like this. In case of custody solutions, very big space. If you are interested to get involved, we have exchange custody like Binance custody, third-party custody like BitGo, and self-custody, different type of custodial solutions that you can think of. And if you are interested to understand how crypto exchanges work, then there is like a whole crypto trading ecosystem that you can understand first. We have opinion leaders that give financial advice. We have exchanges that allow you to sell your tokens or the company's token that you are going to create for other tokens. You have applications and tools, and you have also blockchain agencies about news. And crypto exchanges is a very, very big topic nowadays. And except of the centralized crypto exchanges that you might know, now there are very popular, the decentralized exchanges, where instead to go into a company and say, I want to sell my Bitcoin for the market price now, you can go on a decentralized exchange where the smart contract will actually let you sell your tokens that you bought or the tokens of the company that you plan to create. Okay, and in general, the blockchain startup landscape becomes very, very big. We have blockchain applications in several sectors like consulting, payments, identity, governance, mining, exchange, NFTs, content management, data, provenance and notary, prediction markets. Pretty much the whole sector and set of sectors are being transformed through this new technology. And we have lots of startups in any like space of interest. I'm going to conclude with a very nice example here. You know about Ethereum, right? Ethereum is like the second biggest blockchain based, I don't know if it's like a security or what it can be called. It's like a blockchain. It's the first decentralized computer pretty much. In 2017, they've done their first token offering. They sold the Ethereum for 30 cents. And the project became so successful because the blockchain can offer you this exponential speed up, where the Ethereum now pretty much is considered as the virtual machine for building decentralized application. So I would like to encourage you to start looking into the blockchain space and get involved. If you are working on a startup now, it's good to also check out the blockchain element. Okay, so thanks for your attention. I gave you a lot of information. Hopefully, yeah, that was of interest. Yeah.
A really extensive look into blockchain, actually, without the sort of the technicalities for pure coders, which is exactly what we were looking for, and yeah, absolutely fascinating insight. I'm conscious of the fact there's quite a lot of questions in the chat. We do have a few minutes. I'm just wondering if you wanted to cherry pick a few of those and go through them at all, ones that you weren't able to.
Yeah, before I go, I will write my email here. Okay, so in case that you would like to send me some of these questions, we can take them offline because we have 5 minutes as far as I understand, right?
Yeah.
Okay, so this is my email. Okay, the first is how might the rise of quantum computing impact the security of the blockchain? Okay, very good question. I mean, quantum computing, it's like a set of new algorithms that will be will be in position to break the traditional PKI as we know it now. It will not affect the hashing techniques, okay? But also now cryptographic community is working on devising new standards that will replace the existing PKI. I know it's a technical answer, but it's a technical question, right? I cannot avoid the technical lingo. So the whole idea is that we have new algorithms that we will switch them the existing infrastructure to. Okay, can records be erased without traces? No records can be erased in the blockchain space. It's fully immutable. As soon as it's there, it's there. How anonymity matches accountability and ability to trace transaction? Okay, very good questions, very technical. Again, so I have to give a technical answer. There are cryptographic primitives like zero knowledge proofs that allow you to make transactions in a way such that they look to be random for someone who does not have the authorization, but at the same time, they can prove to be valid. Okay, they are called zero knowledge proofs in case there is interest to learn more about how this stuff is being guaranteed. Okay, as the ledger gets bigger, more transaction, does the nodes need to get bigger in terms of storage, or there is not a real limitation? It really depends on the blockchain space. If we are talking about small hashes, I mean, this is not an issue. If we are talking about a private blockchain and we store more information except of the fingerprints of the transaction, then this becomes problematic, but still in the private space, this is not a problem. Okay, since the ownership is not clear and not transferable, will it not negatively impact regulations and government law across the world? Regulations and government, it's a gray area. There is no government that really tried to regulate 100% this technology. So ownership is very clear, by the way, because there is something called secret key that can be used in order to prove that you have done something. But I don't have the answer because the government also do not have the answers yet, how they can impose this, right? What are the use cases where decentralization is really of prime importance without the need for regulatory? We are not talking about decentralization always. We need to remove someone. Maybe there are cases where there are inefficiencies, multiple middle parties being involved. That's a case why we would like to have the blockchain ecosystem. The validation of a block is done simultaneously by many nodes. Studies on how much energy is needed for this is horrifying. How does this fit together with climate change? Okay, I mean, there are certain consensus algorithms like the ones being used by Bitcoin, proof of work, that consume significantly higher energy than the others. Okay, they have, let's say, high carbon dioxide footprint, but now we have a new generation of consensus algorithms like proof of stake that are not heavy in terms of computation, and thus they do not have heavy carbon dioxide footprint. Okay, so we are transitioning into more environment-friendly algorithms and blockchains in general.
I think if we just go to the last question there that's just been posted about the suggestions of learning about digital currency investing.
Okay, regarding investing, it's like a tough question. I mean, from my point of view, the best thing is to go and read the projects, understand the projects, and do not go into like gambling. Understand if there is a real use case of something, if there are strong fundamentals behind it. Okay, that's the main like thing. Regarding learning suggestions and that stuff, you have to follow the certain, I don't know, news agencies to get informed about the new trends and what is coming out, and follow the milestones and the like timetable horizons of each of the projects that we are following, and see if they deliver what they promise. Okay. I think we don't have time for more questions.
I think we'll wrap it up. Well, I just want to bring your attention to the fact that we've had a wonderful comment on there, which I'm sure reflects a lot of sentiment from the extensive audience we've had on today, to say that was the greatest blockchain intro that they've ever seen. So really a huge thank you. And just for you guys online, if you haven't read the comments in the chat, do follow the @LBS Crypto on Twitter to stay in touch with what's happening with blockchain at London Business School. And of course, do reach out to Theo with any questions, or just for your words of thanks. That was absolutely superb. It really was. Thank you so much.
Thank you all.
You guys all enjoyed it. Thank you so much.